Hello friends, welcome to your own channel on artificial intelligence and machine learning. Knowledge of SQL programming is a must for any data scientist. And as part of our this playlist, we are learning SQL programming for data scientist. So far, we have covered DDL, DML, indexes, select queries. We have reached till functions. In last video, we detailed various functions, and in the previous video, we had joins. We also covered subqueries, common table expressions. I hope you have seen those videos. In this video, we are going to discuss window functions. As already mentioned, window functions are analytical functions. What we are going to cover as part of the window functions, this will be divided in two videos. In the first video, we will cover the concept of window functions, and then we will discuss the three important window functions: rank, dense rank, row number. Besides these three important window functions, we also have to learn about lead, lag. These are another two important window functions one should be knowing. First value, last value, and so forth. There are few more window functions like cumulative, distribution, Ntile, and so forth. So these window functions, when they are used along with certain clauses: over, partition, order, preceding, following. These are various input parameters which we can use while using the window functions. So let's get started, because unless you use them practically and understand the concept of window functions, you will not be able to understand the importance of these window functions, which are very important while doing any analytics. So let me try to explain these window functions. I have a sample data, as you can see on the screen. First, what I would do is explain the window functions using Excel. Once you understand the concept, you will be able to better appreciate the need of these window functions. Okay. To begin with, here there is a data of students, and the data is of 5 student ID 1, 2, 3, 4, and 5. The data is for their 4 years of graduation. Each graduation year, what are the student marks, what percentage they secured. Step 1, for the time being, forget these are different students. So for the time being, let's just say these are student ID, and I will simply put them as 1, 2, 3, 4, and like that. I'll just give them, for the time being, let's assume they are different students, they are not same students. I want to rank them. Rank means basically you have to assign who is first, who is second, who is third, and so forth. To do the ranking, what you would do, if you have to do the ranking in Excel, you will first do data sorting. and you will sort the data by student marks, largest to smallest, and we would like to assign rank 1 to students who have the marks 100 S1. Then we would like to assign the next highest student marks as rank 2, but here there are 2 students who are already at rank 1, so probably we will assign the rank 3. Now here there are 3 students with rank 3, so here we will have to assign rank 6, then 7, 8, 9, 10. Now there are 2 students with rank same numbers, so 11, 11, 12 will be skipped, 13, and this is how we will do the ranking. Let me just quickly fill the numbers. So we have given the ranking to our customers. This is called the concept of ranking. Now here you can see that some rank numbers are missing. So the other way of ranking would be, which we call as dense rank. In dense rank, the numbering would be 1, 1. Because there are 2 students who already have the rank 1, we are not going to skip the rank 2. We'll start with the next rank number. I hope you get the concept of rank and dense rank. And then this would become 3, 4, 5, 6, 7, 8, 8, 9, 10, 11, 11, 12, 12, 13. The difference between rank and dense rank is you do not skip the intermediate rank numbers. Here you skip the rank. And then there is a concept of row numbers. Row numbers, as you can understand, is simply giving row numbers. Here what you will do is simply sort the data based on the column which is of importance and simply assign the row numbers. So we have understood 3 window functions: rank, dense rank, and row numbers. Now how to write SQL queries for same is what we are going to understand. So let's get started with MySQL. This is the tool we have been using. Let's create a sample table and populate the data. What I'm going to do is, this column anyways is temporary column I inserted. I hide it. We will create a data with this values. So first I will, if the table already exists, yes, it already exists in my machine, so I'll drop it. I'll recreate the table. This is the syntax to create the table. Shift Control Enter. I created the table and these are the syntaxes to insert data. You can pause the video, write the syntaxes. I've inserted the data for first year, 5 entries I've made. Now second year, 5 entries. Third year, 5 entries. And fourth year, 5 entries. Total 20 observations I have inserted, and the data is as shown on the screen. This is the data that we have created. Now let's see the syntax. First syntax, row number. What we are doing is we are saying select star and then we say row number over as. I'm giving a alias. Okay. Now here I have not passed any parameter by which column you would like to do the row numbering. So let's run this syntax and see what output we get. I simply run this query without passing parameter to over, and what you see is data is simply numbered based on the sequence in which the data is in the table. So the purpose of over clause is the column by which you would like to do the ranking or row numbering. So here what we'll do is we will specify over student marks. Let's run this query now. It gives error. It says student marks is not defined. Let me just check the columns. Stu marks is there. Okay. I have not specified the order by. As such, I got the error. I assumed it would automatically take order by. Okay. Now, order by student marks. By default, the ordering is ascending. As such, the lowest mark record has got the numeric value 1. Please note here we are assuming that these are 20 records. We are not at this point of time considering the student, same student coming multiple times and the graduation year. Okay. This is the scenario. This is the scenario which we are handling, where we assume these are different students. Okay. So I would like to give rank number 1 to the student who has got the highest mark. I have to use the descending clause. Now the student who has got the highest mark 100 has got the row number 1, but this student who also secured 100% has been given row number 2, which is not the right approach of giving ranking. But this, as you know, is a row number function. So what we need to do, we need to, instead of using row number, we may have to use a rank function. So this is the additional column which we have to introduce, rank function. I'm going to build this syntax gradually. This time we will use row number and rank, both of these functions, and see the output. This time around, you can see the rank has come 1 1. The rank number 2 has been skipped. Then we get rank 3 3 3. Okay. But I would like to assign this record rank number 2. I don't want any intermediate rank to be skipped. In that case, you have to change the query and say dense rank. So this is our next query. Here we have dense rank, and now we execute this and see the output. You can see the rank numbers are continuous. This, I hope you have understood the row number, rank, dense rank. Now in this entire analysis, what we did, we assumed these students to be having different student ID, but actually it is not the case. The data is actually, the students have data which is for different graduation years. So once again, let me sort, and this time I want to sort the data by graduation year, smallest to largest, and within the graduation year, I would like to sort the data by student marks, largest to smallest. And the way I would like to have the ranking done is I should be giving ranks within a graduation year. In that case, I need to do partitioning. What I mean is, when I'm ranking the students who are in a graduation year 1 based on their graduation year 1 percentage, I should be having 1, 1, then this is ranking, so 3, and this should be 4, and this should be 5. For the next graduation year, the number should again start with 1. 1, 1, 3, 4, and 5. Here the number should be 1, 2, 3, 4, and 4. I hope you get the point that we need to partition the data. I have shown this for one of the columns. I'll hide these two because these are older ones. But now what you can clearly see, the ranking is done separately for this set of data. The ranking is done for graduation years separately. Within a given graduation year, we are comparing the students and checking who was first rank, who was second rank, who was third rank, and who came fourth rank. Which means I need to do partitioning. I hope you got the concept. Okay, how do we now write SQL syntax for this? If I simply put where condition, then I would be doing the ranking only for one graduation year. If I have to then do the ranking for second graduation year, I'll have to write the query like this. But this would become cumbersome. I am putting a filter condition, and only for one of the graduation year I'm doing the ranking or dense ranking. But what we really require, in one go for all graduation year, I should be able to do the ranking or dense ranking. Row number is just kept because row number in this case is not relevant, but I have kept that in my syntax. Okay. This is a small practice exercise. Modify above query to show records of only those students who secured the first rank in the class. So if I have to modify this query and get only those students who have got the first rank in the class, assuming we are doing it for graduation year 1, what change you will have to do? Pause the video, try to answer yourself. Okay, let me give the solution now, and we'll have to put one condition further equal to 1. The reason why I have put underscore is because these are functions. If I don't put underscore in the column names, unknown column rank. Oh, my mistake. This column is not a column which is in the main set of table. This column is not there in the original table. This column is something which we have created as part of our summarization. So I should be writing this something like this, having rank equal to 1, because if you are applying some condition, you cannot use alias. So it's saying that I cannot use alias. In that case, I'll have to use this entire thing in my query. Okay. It is saying you cannot even use the window function. It is not allowing me to use alias. It is saying that usage of window function is not allowed in the having clause. Then how do I solve this? In my subquery, I had mentioned that you need to know when to use these subqueries. This is an example when we have to use subquery. Select star from, and this entire table we will put in a subquery, give it an alias as, let's just call A, and now we say where A dot underscore rank, and we want student who stood first, 1. Now this query gives the desired result. So this query also helps you understand the usage of subqueries, when to use. Let me remove this result set so you can see the full query. This is the query. Okay, let me undo the changes which I have done. Okay, this was my original query. So I hope you got the solution to the practice exercise. We already covered dense rank, lag, lead. We'll see these concepts. Lag, lead, we'll see later on. Now we would see the partition. This is the subquery solution to the above question. Here I have done the filtering based on dense rank. Okay. Another practice exercise before I get into the partition thing. Find the highest rank holder and the lowest rank holder for graduation year 1. Okay. Just for the time being, let's try to solve this for graduation year 1. How do we change the above query so that we get the highest rank holder and the lowest rank holder? If you have to make changes to this query, how would you go about doing it? Pause the video, try to find the solution. Okay, I hope you got the solution. Copy this syntax, copy. Let's try to give the answer. And here, what I'll do is, rather than having this dense rank, row number, all of them, to simplify it, I want the highest rank holder and the lowest rank holder. I'll have this part. This is highest rank, and what I'll do is copy paste this same thing, and this time instead of doing descending, I'll say ascending, so that the person who is lowest will get rank 1, lowest rank. Okay, from student's grade, comma will have to be removed, where graduation year equal to 1, alias ABC, where this becomes my inner query. And now here I say highest rank equal to 1 or lowest rank equal to 1. Now when you run this query, the two students who got 100 out of 100, highest rank, you have fetched their records. You have also sorted the data and ranked it the reverse direction, ascending, and you have selected the lowest rank. So let me show you the full query once again as a solution to the practice exercise. What is the practice exercise which I had shown? This is the practice exercise. Find highest rank holder, lowest rank holder from the data, and I simplified it for a given graduation year. This is another example of subquery. The same query could have been written with common table expression. We can do select star, rank over order by, from student grade, select star from common table expression where rank equal to 1, or rank equal to select max rank from common table expression. So this is another approach. Here I have not done the bare condition. We need only data for a particular graduation year. So I'll put this where condition also, where graduation year is equal to 1. So this is my common table expression query output. This common table expression I'm going to use to get the data. We have got the same 3 records. So both the approaches, one approach with a subquery approach, one with common table expression, I have explained. Now here in all these queries, what you can see, we have been using subqueries and we have been applying data filter for one graduation year. But what if I want to do the ranking or dense ranking for all the graduation year in one go? That's where we started off, and I had a couple of practice exercises. So let's now jump to that. Partition. What we need to do is we need to add a partition clause. Partition by graduation year. What we are saying is we want to apply the ranking function, we want to apply the dense rank function, whichever window function you specify here, rank, dense rank, row number, lag, lead. What we are saying, we want to partition the data by this column, and the ranking or dense ranking has to be done by ordering the data by this column. Now when we run this query and see the output, let me show the output in full screen. This is graduation year 1, 1, 1, 1, 5 records for graduation year 1, and the dense rank number starts from 1, 2, 3, 4, goes up to 4, and the next graduation year 2, when it starts, once again the partition dense rank number starts from 1. Similarly, you can see the partition rank number starts from 1. Similarly, you see the partition row number value starts from 1. So this is the usage of partition by clause. I hope you have been able to understand the rank function, dense rank function, row number function. In our upcoming video, we will start with lag, lead. We will see windows preceding and following options. Till then, I hope you have been enjoying the SQL sessions with me. If you have been enjoying the sessions, I would definitely expect a like on the video from your side, and be generous enough to share the video with your friends who you feel would be benefited by this content. I would like to conclude the session here. See you in the next session. Thank you. Kindly like, share, subscribe. See you in the upcoming video. Thank you. Bye bye.